Justin's going to share a little bit more about how things are advancing beyond just a single agent to a much more sophisticated AI infrastructure. He also happens to be New Jersey proud, a graduate of undergraduate and his master's degree at Stevens. We give a big round of applause for Justin Trugman.
Thanks, everyone. Let's give one more round of applause for the TechUnited team and Bell Labs for hosting us. It's been a great event so far. Definitely learned a lot.
Oh, I forgot to do it.
Okay, we're good. So, like what Aaron said, I'm going to cover a bit about the different architectures that we're seeing in AI and a little bit about me. So, co-founder, head of technology at BetterFuture Labs. I was an early engineer in the VP of software development at the New Jersey-based telehealth startup Caregility, and then I was also at Google X's Project Loon. And for fun, I like to barbecue, read, play board games. But first, let's define what are AI agents. This is an architecture pattern that if you're following tech Twitter, you probably see AI agents or agentic AI in every single post. But most of the times, it's really not AI agents. And people are just throwing that word around there. And I think it'd be helpful to go into what are the different architectures that are being used, what makes them unique, and what are they advantageous for solving different types of problems. So let's first by defining what are workflows. Workflows are what people are typically calling agents. And think of them like assembly line jobs. They are repeatable, and they do structured processes. So think about someone who is assembling a car. It's typically an assembly line. A lot of it's robots nowadays, but say there's a guy that is attaching the wheels onto the actual car chassis. This is a process where it's the same thing every time. They have the same inputs of the wheels, the same inputs of, say, the screws, the same tools that they're going to be using, and they expect the same, a car chassis to come in. It's structured with that, and there's a process for the order of which bolts you put in first or which screws, and how you actually screw on that wheel. It's a little bit dynamic where, say, the same person can do a sports car, they could do an SUV, they could probably do a pickup truck, but generally it's the same repeatable structured process. And a practical example of this, actually similar to what was mentioned both in the panel and before, is generating Instagram content from top trends using AI image generation. Super common to do. You pick your niche, you scrape the top 10 Instagram posts, then from there you check to see if you have any existing data on it. If you do, great, add that in. If you don't, then you do some more research. Uses an OpenAI model to analyze it and Flux to generate a new image, and then you post it, and then from there you send a little Telegram message to the team being like, hey, it was posted. And this is a workflow that runs autonomously and can consistently run. This is using N8N. We use that tool. There's Make, Zapier's adding some AI stuff, but N8N is really nice. And it solves a real problem. It's just different than an agent. So what is an agent, right? Now that we know what a workflow is, think of an agent like a general contractor. It's flexible, it's autonomous, and it's adaptive. What do I mean by this, right? Say the general contractor gets the blueprint for a house. They generally know what house they need to build, and they need to put the walls up. Well, they could make a decision. I want to use screws, or I want to use nails. And based off that decision, they need to pick what tools they want to use. If you try to use a screwdriver to put in nails, it's probably not going to work out too well. And vice versa with a hammer and screws. So they have to decide, okay, based off of this task that I have, based off of this blueprint, I'm going to choose to put up the drywall with screws. And for that, I'm going to be using this type of drill. And then they need to be adaptive, right? So say they try that out. Say they try to screw in the wall, and it doesn't work for whatever reason. Maybe they switch to a hammer and nail and give that a go and see if that works better. And if not, they might switch to another method of attaching walls. So they're real problem solvers. They're not just task followers. And that's the core differentiation between, say, a workflow where it's a very repeatable process and an agent where it can be a bit more adaptive and autonomous. And getting into a practical agentic example, so this is the cursor coding agent. They use a variety of models under the hood. And this is resolving conflicts while rebasing. If you're a developer out there, you probably know rebasing is one of the ways to integrate your features into your existing code base. And here, I had something where I had a huge rebase I needed to resolve, and I just frankly didn't want to do it. It was not a good use of my time to resolve like 30 rebase conflicts. So I tasked Cursor Coding Agent, and you could see what it did was first it read the file, and then it grabbed the specific tag that it knows. And there's new functionality. Let me resolve these conflicts. And from there, autonomously, it was able to go in, read my code, and resolve all of my rebase conflicts. These types of simple like developer tasks that are super tedious for humans to do, AI does it very easily, and it's super low risk one-shotting it. By one-shotting, I mean just by having the agent do it, and you do a quick skim and go from there. So now that we know what a single agent is and seen an example and workflows, what are multi-agent systems? Well, the name is a bit self-evident. They're systems of multiple agents, but what does that actually mean, right? Let's go one layer deeper. So they're built to divide and conquer complex tasks. So your general contractor, say, has a plumber, could also have like a roofer. And from there, they could divide and conquer the planning and orchestration of those tasks. And they can ensure complete and accurate responses through debate, dialogue, and coach each other. If the general contractor knows that this type of plumbing did not work out last time, and here's why, because of some area and their unique expertise, they could then coach the other agent and go from there. And let's talk about a practical example of this, how BetterFuture Labs leverages multi-agent systems. We have collaborative agent roles to build investment analyses. So we have a variety of different teams of agents within our investment thesis that manage the different pillars. So like market analysis, competitive analysis, if something is technically viable for us to build out, what's the financial viability, and each team has a director that orchestrates it. So it gets a description of the idea, it breaks it down into different objectives of what the team should research and how they should analyze the idea, and then the managers come in, break that objective down to actual tasks, and manage analysts who do the work. And there's a feedback loop going all the way up. So when the analysts produce an analysis, the manager will review it, provide feedback, and then from there, once that's satisfied, they'll go back up to the director, and the director will provide more feedback, make sure everything aligns, and actually format it into an investment analysis for us. And the final output that we get, it's pretty cool. We get a really in-depth investment memo, and then some comparative analysis dashboards so we could compare ideas across our studio. One last thing that I would like to talk about is benchmarks. There's a lot of benchmarks that people see. My favorite one is Gaia, and it was actually developed by a Bell Labs alumni, Yanlei Kuhn, who's the chief AI scientist at Meta. And what Gaia does is it assesses the performance of AI systems to do essentially very tedious but achievable tasks for humans. And what these tasks look like are multimodal step processes of search, of math, of solving problems that I believe humans score 93% overall in the benchmark, and AI systems are trying to keep up. And I think it's a very good kind of tracker as we go into, it was mentioned a little bit before about AGI versus ASI, AGI being matching human capability. This is a good barometer for how close are we actually there. And you can see it's broken up into 3 different scoring tiers. So there's level 1, which is the easiest, level 2, which is more challenging, and level 3, which is just super tedious tasks that would take like humans 20 minutes and hopefully in 5 years AI systems like 30 seconds. So yeah, thanks everyone for the time. Hope this was helpful. And we have 2 companies that we're working on right now at BetterFuture Labs that we'd love you guys to check out. And we're actually hiring for co-founders of those companies to help co-found that and bring it to market with us. Wave, which is in the water damage restoration space, and Casey, which helps turn like literally hundreds of hours of like deep social media investigation for insurance fraud into just minutes. So yeah, thanks everyone.
All right. Thank you, man. Thank you very much. Let me get the clicker.